And today we're going to be talking about pointers in C++. So in C++ we have very many different types of objects. We have ints, we have doubles, chars, strings, vectors, everything. And all of those objects have something in common, and that is that they live somewhere in memory space. And we cannot actually actively control where an object lives in memory space. The compiler does that, and the computer does that, and we're not involved at all in that. However, we can ask the compiler and the computer to give us the address of an object. The address of an object is where in memory space it lives. So if we have int x equals 5, now we can easily tell that x has a value of 5. So we draw a memory diagram, and we have x is equal to 5. However, where does x live in memory? To answer that, we can just simply run this line of code. This ampersand operator returns the address of a variable, that is where in memory it lives. So for x, this could be something like 1000. And to us, that really doesn't mean anything, because what do we care that an object lives at memory space 1000 in our computer? Well, this allows us to do one thing. This allows us to create things called pointers. What a pointer does is it stores the address of a variable, and then it points to it, which means that we can dereference the pointer and get the object itself. So we create a pointer as follows. This int star tells us that we would like a pointer that points to an int. So this int can actually be replaced with anything, a double, a string, a char, any type of actual object that we can create in C++. The star indicates that this is a pointer, so it actually doesn't hold its own value, it just holds an address to a value. And the ampersand x, again, is the address of x. And so how this looks in memory is we have pointer, and what it stores is actually the address of x. So it points to this object in memory. So this could be like address like 6000, and this could be address 1000, and the pointer could live at address 6000, and x could live at address 1000. And so we can follow the pointer to x. And how do we do this? Well, if we see out this code actually will dereference a pointer. Dereferencing a pointer means that, hey, get the value of the pointer, which is just the address that it holds, and then follow that address, get to the object, and then give me that object. So this will actually print out 5, because x is equal to 5, and pointer points to x. So this is fantastic. We can indirectly reference different objects. So what else can we do with this? Well, we can reposition pointers. So we can create int y is equal to 7. And then we can say, hi, pointer, can you please point to y now? And so in memory this looks like y is now equal to 7, and pointer points to y now. That is, if we were to see out the value of pointer, we'd get 7. So what else can we do? Well, if we say that star pointer is equal to 12, what this does is it says follow what pointer points to, as we discussed that that's what the star operator does, dereference it, and then set it equal to 12. So what this does is we follow pointer to y, and then we set it equal to 12. So now, if we see out y, that's actually going to give us 12. So this is great. We can actually change objects without ever touching them, just through the pointers that point to those objects. And so another thing that we know is that pointers have their own address. That is that they also live somewhere in memory. Now we can use this to create a pointer to a pointer, but I mean that doesn't have it very, very many uses, but that's also a object. And then so yeah, that is pointers in C++.